Do I need to get my music mastered? This is a question that musicians have been asking for decades. I remember asking this question myself when I was first getting started in recording music. What makes this question so unique is that there's so much mystery around what mastering actually is and the skills required to master a record. But don't worry, because in this video, I'm going to help you understand what mastering is, why it's important, and whether it's best or even possible to master your own music, or whether you need to hire someone else to do it for you. Thanks to Music Hack for sponsoring this video and supporting audio education. Music Hack has a plugin called Master Plan that not only makes some of the key parts of the mastering process easier to understand, but it does so in a way that's useful for both beginners and advanced professionals. Use the link in the description below this video to download a free demo of the plugin, and let me know what you think in the comments below. If we're going to understand what mastering is in modern day production, it's helpful for us to understand the origin of mastering back in the days of tape and vinyl. Before digital audio became mainstream, music was recorded to magnetic tape. Typically, there would be a multi-track tape recording where each instrument was recorded to a separate track. Then the mixing engineer would use various tools to create a balanced mono or two-channel stereo mix that could be recorded to a mono or stereo tape machine. This process is similar to stereo mixing today. We start with multi-track recordings in a DAW and eventually mix those down into a stereo audio file. There are several differences between the old way and the new way, including the possibility for more channels, more flexible workflows, and of course, plugins. The primary difference I want to highlight here is that a stereo audio file can be easily uploaded to streaming platforms or burned onto a CD for distribution. A digital file can theoretically be copied and transferred thousands of times without experiencing audible degradation, and most listeners will have a device at home that can play digital audio files. However, a stereo tape mixdown cannot be easily replicated for the masses without quality loss, and most listeners don't have a reel-to-reel tape machine at home. Therefore, the distribution medium in the analog days was vinyl disc. The tape mix would be cut to a master disc that would then be used to stamp several vinyl discs for distribution to the public. There were several challenges associated with transferring a faithful copy of a stereo mix from tape to vinyl, and therefore the process required a skilled technician. And also, a vinyl disc is significantly less capable than magnetic tape in many ways. For one, magnetic tape can generally facilitate a signal with lower noise, higher fidelity, wider dynamics, wider stereo separation, and wider bandwidth. That meant if you tried to transfer a song straight from tape to vinyl without altering it at all, it would potentially cause a lot of problems. For example, during playback, the stylus may jump out of the track, thanks to the mechanical limitations of vinyl playback. A mastering engineer therefore needed to use a variety of tools, such as compression, EQ, etc., in order to create a version of the album that could be distributed to the masses while preserving the integrity of the mix. This is still somewhat the case today, even though modern distribution media are much more capable and forgiving. The mastering engineer receives a digital stereo mix from the mixing engineer containing only two audio channels, left and right. Their job is to put any final touches on that stereo file to ensure it's optimized for the best possible experience when delivered to the listener. Let's get into the basic processes of mastering a song today. If I miss anything, please leave a comment below. The first thing that a mastering engineer will typically do is ensure that there are no technical problems with the stereo mix they receive from the mixing engineer. This could include removing clicks, noises, and artifacts, adjusting phase rotation, or any number of things. Clicks, pee-pops, guitar squeaks, and other noises should ideally be removed in the mixing phase. In fact, that's the case with many of the tasks that are often left to the mastering engineer. But the mastering engineer is the final stop before distribution. So if there are any remaining noises or artifacts that detract from the intention of the music, it's up to the mastering engineer to remove them. Today, this can be done with a level of precision and transparency that has only been made possible relatively recently, thanks to modern plugins. For example, engineers can now view audio signals with a spectrogram and highlight not only a particular period of time, but also a particular frequency range. Then the plugin will interpolate the most transparent way to attenuate energy within that range. Another fine detail that many pro mastering engineers will look at is the phase rotation on each channel. While this will not impact the perceived loudness of the song or the RMS values, it will potentially impact the peak values, which have implications on the headroom available. As you'll see later in the video, headroom is an essential principle in mastering, and especially in modern mastering styles, headroom is a very valuable asset. I'll admit I'm still learning a lot about this myself, but if you want to learn more, I'd recommend checking out a series posted by Adam Audio on their YouTube channel. Starting with this cleanup step is a good idea, because later on in the mastering process, the dynamic range of the song will likely be decreased, which will potentially make small noises more and more noticeable. But now that we've discussed the technical cleanup, let's move on to the fun part. A mastering engineer is responsible for making the song or album sound good, not only on an amazing full-range studio monitoring system, but also on a wide variety of other listening systems. I mean, let's face it, most people will be listening to music on a very limited system, and we want it to sound good for them too. Now, you'll notice I didn't say a mastering engineer is trying to make the music sound the same everywhere. That would be a fool's errand, because you can't make smartphone speakers sound like a pair of studio monitors with a subwoofer. You just can't. A much more realistic goal is to ensure that the essential elements of a song come through regardless of the playback system. Again, this is something that you can and should consider throughout the mixing process as well. In the Master Plan plugin by Music Hack, there are a few buttons on the right side that allow you to model what the master might sound like on different systems, such as a bookshelf speaker or a phone. You can band limit the output of the plugin to check that the essential vibe of the music is coming through in the mid-range. Just remember to turn these switches off before rendering your final master. Either in the mixing or mastering phase, the pursuit of a mix that translates well to other playback systems can include making changes to the energy levels throughout the frequency spectrum. One example of this is to remove extraneous frequencies, particularly in the low end. If a mix has energy at very low frequencies, that's fine, but if the energy doesn't contain musical information that serves the record, it may be best to remove it. Let's say there's energy between 20 and 30 hertz when viewed on a frequency analyzer, but that energy seems to originate from rumble in the room or some other non-musical source. Or maybe it's from a musical source, but doesn't serve the intended listening experience. There's a principle in audio, the upward spread of masking, which tells us that lower frequencies will tend to mask higher frequencies. So while it may seem like the extraneous low frequencies are harmless, they could in fact be making it more difficult to hear the other frequencies higher in the spectrum. One way to address this might be to use a high-pass filter to remove those frequencies, which could potentially improve the mix on both full range and band-limited systems. Sending 25 Hz to a Bluetooth speaker is only going to make that speaker's job more difficult. So if it's not needed, it's probably best to remove it. Beyond the extraneous frequencies at the boundaries of human hearing, a mastering engineer will also take a listen to the frequency balance throughout the spectrum. But remember, the mastering engineer is only dealing with the stereo mixdown, therefore they're not able to make changes to only a single instrument. Another potential advantage to fixing some of these problems in the mixing process. Every change the mastering engineer makes will be applied to the mix as a whole. For example, if the mastering engineer finds that the bass and the guitar are interacting in a way that creates mud in the low-mid range, they can apply a subtractive EQ to the low-mid range. However, that will reduce the energy in both the bass and guitar, and all the other elements in the mix with energy in that range. For this reason, the EQ changes made in mastering tend to be a bit more subtle than those made in the mixing phase. The way mastering engineer Jonathan Weiner once put it, applying a 3 dB cut at 250 Hz to a stereo mix is akin to applying a 3 dB cut at 250 Hz on every single channel of the multitrack. In other words, a little goes a long way. Mastering engineers tend to make wider tonal adjustments rather than precise surgical adjustments, although that's not a hard fast rule. You can see that the Master Plan plugin offers 3 bands of EQ for tonal shaping: low frequency, mid frequency, and high frequency, with a high, mid, and low frequency selection switch for the mid band. These settings can be used to make adjustments up to plus or minus 8 dB, so the mix sounds more balanced according to the genre and the intention of the artist. There are many ways to use EQ in the mastering process, whether it's a creative enhancement of a specific frequency range with a boost, or a cut to reduce the masking effects of a specific frequency range, or anything else. Don't forget that this is a science and an art. So I'd recommend downloading the free demo of the plugin to experiment within your own music. Masterplan offers ways to shape the frequency balance with more control for those who know how to achieve the desired effect, but it also offers simpler switches that could be useful for both advanced engineers and beginners, such as the clean switch to remove the mud in the lows, and the calm switch to tame the harsh high frequency buildup. When you engage each switch, you'll see a slider to adjust the amount of each effect. Just like cleaning up the small technical errors in the beginning can help make a mastering engineer's job easier later on in the process, so can balancing the energy throughout the frequency spectrum. This is particularly helpful when the mastering engineer intends to limit the dynamic range of the music. Think about the behavior of an EQ and a compressor working together. If there are frequency imbalances in the signal prior to reaching the compressor, the most prominent frequencies will trigger the compressor's threshold. By first reducing the energy in a particular frequency range with EQ, you can potentially improve the performance of the compressor that comes afterward. This isn't to say you should aim for a completely flat frequency response throughout the frequency spectrum, but rather that the various tools used in mastering, like EQ and dynamics, are an interconnected system and should be approached as such. I'm not going to get into the whole idea of the loudness wars in this video, although I'm open to exploring that topic in a future video, so if you're interested in learning more about that, leave a comment below. The loudness level of your master should be determined by the values and intentions of the artist and everyone involved. There's no right or wrong answer here. What I will say is that mastering engineers are very often trying to make a mix as loud as possible while maintaining the impact, clarity, and overall feel of the mix. And this comes with a few challenges. If you want to make your mix louder, you have to turn it up. I know, revolutionary information. Thank you for your time. I appreciate you watching. See you next time. Okay, jokes aside, you can only turn up the mix so far before the peaks of the waveform exceed 0 dB full scale, or 0 dB FS. When this happens in a fixed point digital system, clipping will occur, and this can sound terrible. I'll quickly mention that the 0 dB FS limit is the absolute maximum, but mastering engineers will usually target a peak level below 0 dB full scale for a few reasons. One reason is that even if the meter shows a peak level of 0 dB full scale, there may still be moments between samples where the signal level exceeds 0 dB full scale during the conversion process. To address this, mastering engineers will look at the true peak levels in addition to peak levels. Another reason not to go all the way up to the theoretical maximum level of 0 dB full scale is that most streaming platforms and other delivery formats will include some sort of data compression algorithm prior to reaching the listener. In those cases, leaving even a tiny bit of headroom can go a long way toward preventing distortion during that data compression process. Okay, so let's say you want your final master to have a true peak value of minus 0.1 dB full scale. You turn up the overall level of the mix until the true peaks of the waveform reach that level, but you still want the mix to sound louder. At this point, you could carve out some more headroom with EQ in a particular frequency range, or you could use dynamic range compression or limiting, where the signal level will be reduced when it exceeds a set threshold. But compression and limiting come at a cost. When you dynamically alter the dynamic range of a waveform, you change the shape of the waveform, which results in harmonic distortion. These two things are one and the same. Changing the shape of the waveform, you distort the waveform, and distorting the waveform, you change the shape. There are many different types of limiters and compressors that will behave differently, and they're all potentially useful for various situations. In the world of mastering, engineers often want a limiter that will allow for the mix to be louder without causing excessive distortion, often referred to as a transparent limiter. This is the goal of the limiter within Masterplan, to make the mix louder while maintaining maximum clarity. In fact, the developer behind Masterplan, Sam Fishman, previously joined me for a discussion on this very topic with a lot of visual and audio examples, and I really recommend checking out that video if you're interested in learning more. Sam is an amazing teacher, and I learned a lot from that conversation. In Master Plan, there's just one knob for controlling the amount of limiting. If you want it louder, turn up the loud knob. At a certain point, you will start to hear some audible distortion, but that point comes later than expected compared to some other limiters on the market, thanks to Music Hack's proprietary programming. I can't reiterate this enough. Mastering is an art and a science, so use your ears first and foremost, but meters can be helpful. Master Plan allows you to define an LUFS target, loudness units full scale, and will show you where you are in relation to that target with green, yellow, and red indicators. One common reason to use a mixer or compressor in mastering is to gently tame the dynamics of a recording and add some so-called glue. And this is the idea behind the smooth button in Master Plan. But it's not the only reason to use dynamics processing, so experiment. There are times when you want to avoid harmonic distortion, and there are times when you want to embrace it. This is where saturation comes in, which is related to frequency and dynamics. As I've already mentioned, you can saturate a signal with a compressor or a limiter, but you can also use a dedicated saturator plugin to achieve similar results in a more controlled way. You'll see a few options here in Master Plan depending on the type of saturation you're listening for. The thick button engages some analog-inspired saturation, and the tape button emulates the effects of magnetic tape. Again, each one has a slider to fine-tune the amount of the effect. While it might seem limiting to have only a loud knob, pun intended, forgive me, it can actually be very freeing if the behavior of the limiter gives you the results you want without too much fuss. But there are times when a mastering engineer will want a bit more precision. For example, remember when I mentioned the possibility that a lot of energy in a particular frequency range could impact the behavior of the compressor or limiter? Well, what if you like the frequency balance as is, but want to compress the dynamic range within a particular band? This is where either a dynamic EQ with frequency band dependent thresholds could be helpful, or this could also be an opportunity to use multiband compression with multiple compressors dedicated to particular frequency bands throughout the spectrum. In Master Plan, we can select the multi-switch to turn this limiter into a multiband limiter. When this is enabled, the L, M, and H sliders control the amount of gain reduction in the low, mid, and high bands of your mix. Think of a multiband compressor as a compressor for each of these frequency bands, allowing you to achieve gain reduction within one band without compressing the entire signal. This is one of the biggest tasks of a mastering engineer, using the available headroom in a way that maintains clarity, tonality, and dynamics that are in line with the intention of the music. It warrants a dedicated series of videos and can't possibly be completely covered here. If you want to learn more, check out Jonathan Weiner's series on the Isotope YouTube channel, as well as the video I made with Sam Fishman from Music Hack. While I mentioned earlier that moves made by the mastering engineer will be applied across the board to the full mix, that wasn't entirely true. You could, of course, make adjustments to the left channel without impacting the right channel, or vice versa. But more commonly, you might choose to make adjustments to the elements in the middle of the mix, separate from the elements in the side, thanks to mid-side, or MS, processing. For example, enabling the wide feature in Master Plan allows you to widen the stereo width, and the basic principle behind this is really interesting. With mid-side processing, the left and right channel can be matrixed into the mid and side components. The mid component is the information shared between the left and right channels, while the side component is the information that is different between the left and right channels. Mid-side can be used to widen or narrow the stereo width, but with some plugins, it can also be used to apply EQ or compression to one component independent of the other. This could mean removing some low frequency information from the side while leaving the mid as is. It could also mean adding some high frequency energy to the side, removing mud from the mid, tightening the dynamics from the mid or the side, or any combination of things. You won't be able to pan individual elements directly as you could in the mixing phase, but you can get creative with mid-side and other tools I've discussed in this video in order to achieve much more precise control than you might expect possible with just a stereo audio file. At this point, you may be starting to think, a lot of this stuff sounds like mixing, Why would I choose to hire someone to master my music when I could just take care of it myself in the mix? And that's a great question. I asked this question myself when I was first starting to grasp what mastering engineers actually do. And I hope that you're starting to see at this point that mastering is not some secret dark art that only true masters can access, but it's another skill, like recording or mixing, that you can learn. However, there is still something to be said for the idea of the mixing engineer and the mastering engineer being different people. First of all, the skills required to be a great mastering engineer have some similarities to the skill set of a mixing engineer, but there are also some additional skills required. Second, it's common for a mix engineer to struggle with the idea of completing a project. The mix can always be better. There's always another small tweak that can be made, but eventually you just have to call it done and release it into the wild. So if that's the case, if it's already difficult to part with a nearly perfect mix, then adding the mastering process to your plate will likely only prolong that battle with perfectionism. If a mixing engineer tries to master their own mix, they could potentially hear problems during mastering that tempt them into opening up the mix to make adjustments to individual instruments, rather than doing what they can with only the stereo mixed out. When a mastering engineer receives a mix, the boundaries are acknowledged immediately. In some extreme cases, they might request a change to the multitrack mix, but for the most part, they'll do the best they can with the stereo mixdown, and that will be the final product. This gets to another important reason why hiring a mastering engineer could lead to a better finished product than mastering on your own. And that's the idea of a fresh perspective. The mixing engineer has been with the tracks for an extended period of time. They know the nuances of each track unlike anyone else. But this intimacy with the mix is an asset and a liability. In many cases, the mixing engineer's familiarity with the content could stand in the way of truly listening to the mix objectively. Handing the mix over to a mastering engineer who has no preconceived notions opens the door to a much more objective listening with fresh ears. It's just like anything else. In this case, 4 ears are better than 2. Getting a second opinion, a fresh perspective, is usually going to have a positive impact on the end result. That's a good segue to mentioning the Audio University membership community. Every month, members get the opportunity to submit a mix for review by one of our expert reviewers, which offers a fresh perspective on the mix by someone with the experience required to offer meaningful, constructive feedback. Not only that, but members also get access to the Audio University course library, as well as new exclusive members-only content each month from some of the best audio educators in the world. If you're mostly self-taught from YouTube, becoming an Audio University member will help you grow faster than ever before. There's a link to join in the description below the video. The days of going to the store to pick up your favorite band's new album, taking it home to your turntable, and listening to both sides straight through. Those days aren't necessarily over, but that certainly isn't the norm these days. Most people choose to stream one song at a time thanks to the convenience and selection offered by music streaming platforms. However, that's not to say that a cohesive album is an irrelevant concept. The mastering engineer has a unique opportunity to look at each track as a component of the whole album, rather than getting too wrapped up in a particular mix. In fact, this is one of the key roles of a mastering engineer, to ensure that each track on the album progresses smoothly into the next. This can include fine-tuning the transitions between tracks, the tonal and dynamic character throughout the album, and overall just creating an album of tracks that seem to go together, perhaps creating an album that is greater than the sum of its parts. One example of this calls back to the idea of dynamic range and perceived loudness that we discussed earlier. This time, considering the relative loudness of each song and how that will impact the listener's experience. A helpful tool here is an LUFS meter, as it provides an objective, quantitative measurement that can serve as a reference point for each track in an album. There are many different loudness meters available, and Master Plan has one built in, as we've already seen. You don't necessarily need to set the same exact target for every track, but using a combination of metering, listening, and intuition helps a mastering engineer strike the right balance. Considering the listener will have the ability to play any individual song on demand, the mastering engineer must also make decisions that allow for each song to be a standalone piece, which can be complicated in cases where each track flows into the next, as heard throughout Pink Floyd's Dark Side of the Moon or Daft Punk's Random Access Memories. Seemingly small details like these can have a big impact on the experience that the listener will have with the music, and it's the mastering engineer's job to think through the different scenarios and variables that could come into play when the music is distributed. That includes the technical and the artistic aspects, which brings me to my next point. An audio file may seem to contain only audio, but it potentially contains a lot more than that. For example, if you navigate to an audio file on your computer and select Get Info or Properties, you'll see that the file also contains metadata. This metadata often includes the track name and artist name at a minimum, but it can also include the album title, who wrote and performed the song, and other information that describes the audio file. The album cover can also be embedded into the audio file as metadata so that the album artwork shows, in addition to all of the previously discussed information, when connected to a car stereo, as an example. This can sometimes be done by someone other than the mastering engineer, but a mastering engineer will probably understand the process and software required to do so in cases where they are responsible for collecting and embedding the metadata themselves. In addition to these typical pieces of metadata, there's another very important piece of metadata that you may overlook: ISRC codes, or other codes for tracking plays and streams. ISRC codes are issued by the RIAA, Recording Industry Association of America. These unique codes allow for advanced analytics and tracking of radio plays, streams, and royalties. This topic requires a full video on its own, as many of the topics I've discussed today do. But it's important to recognize that a mastering engineer's job may extend beyond the realm of audio. The point of this video isn't to overwhelm you into thinking you need to hire someone to master your music. As I've already mentioned, I think you're capable of learning to use the tools of the trade, such as Master Plan, and developing your skills to the point where you could be the mastering engineer. At the same time, I hope this video has helped you to see that there might be more to mastering than you initially thought. But more than anything, I want you to grasp that mastering, like mixing or anything else really, comes down to the intention behind the music and the purpose of the track. If you just want to create music you're proud of for your own use, try mastering your music with a plugin like Master Plan or the others that are available. If you want a fresh perspective and the work of a trained pro, hire a mastering engineer to put on some finishing touches and cleanup. If your intention is to win a Grammy or be integrated into a film, commercial, or television show, it probably makes sense to work with someone that can ensure the final audio file has all of the necessary metadata. Use the link below for a free demo of Master Plan, and check out the video I made with Sam Fishman about clipping and limiting, which is on your screen now. I'll see you there.